Hello students, so in this lecture I'm going to start a new topic, that is programmable interrupt controller 8259. What is the purpose of programmable interrupt controller? As we know, interrupts can be used for a variety of applications, and each of these interrupt applications require a separate input. So each of these interrupt applications require a separate input. Now if we are working with an 8085 microprocessor, we know there are 5 types of interrupts. They are trap, RST 7.5, RST 6.5, RST 5.5 and INTR interrupt inputs. We know this 8085 has 5 interrupt inputs. Now for applications, for many applications where we have multiple interrupt sources, like we need more than 5 interrupt sources using this 8085 microprocessor, then we have to use some external device called priority interrupt controller or programmable interrupt controller. So by connecting programmable interrupt controller, it is possible to increase the interrupt handling capacity of this 8085 microprocessor. Initially, how many interrupts were present with 8085? 5 interrupts like trap, RST 7.5, RST 6.5, RST 5.5 and INTR. These all are interrupt inputs, interrupt pins. Now by using this 8259 programmable interrupt controller, we can increase the interrupt handling capacity of this 8085 microprocessor. So here it is shown a connection between this 8259 and 8085 microprocessor. So this 8259 is commonly used programmable interrupt controller, which is specially designed for use with INTR and INTA bar pin of 8085 Intel 8085 microprocessor. As you can see, this 8259 is connected with the 8085 microprocessor through this INT pin as well as through this INT A bar pin. Through these two pins, it is basically connected to the 8085 microprocessor, and then there are data lines through which 8259 gives the address to the 8085 microprocessor. So this 8259, it can manage 8 priority inputs. As you can see, this 8259 has IR0 to IR7 lines. So these are the interrupt inputs to which the interrupt application can come. So each interrupt input can handle one interrupt application. So it can handle, this 8259 can handle at a time 8 interrupt applications at each interrupt input. So this is equivalent to providing 8 interrupt pins on the microprocessor in place of INTR pin. As this 8259 is connected with INTR of 8085 microprocessor, so what it is doing, it is actually increasing the interrupt handling capacity of 8085 microprocessor from initially 5 input interrupt pins to this 8 plus 4. So it is giving 8 interrupt pins plus 4 trap, RST 7.5, RST 6.5 and RST 5.5. So it has increased the interrupt handling capacity of the microprocessor. Now by cascading 8259, if I cascade, or you can say if I cascade or connect 8259 programmable interrupt controller to this 8259, if I am connecting the 8259s to this 8 interrupt pins to this master 8259, so this 8 8259s will be called the slave 8259s. They will be called slave, and to which this 8259 programmable interrupt controllers are connected, then this 8259 will be called the master programmable interrupt controller. So what I'm trying to say is that by connecting eight more 8259s to this 8259 programmable controller, which is actually connected to the 8085 microprocessor, it is possible to get 64 priority inputs. So we can increase the interrupt inputs in this way by cascading process also. So let me show you how this, what I am trying to say is, this is the master 8259 programmable interrupt controller, which is actually connected to the 8085 microprocessor, and to this master 8259 at each interrupt inputs IR0 to IR7, to each 8 interrupt inputs, the individual 8259s are connected. So here I have shown two. We can connect 8 8259s to this master 8259. So these 8259s will be called slave, and to which they are connected, to which programmable interrupt controller they are connected, that will be called the master programmable interrupt controller. Now let's see the block diagram of 8259. Let's discuss the block diagram of 8259. So this programmable interrupt controller is having data bus buffer. It allows 8085 to send, it allows this 8085 microprocessor to send control words to the 8259 and read a status word from 8259. So the 8-bit data bus buffer also allows 8259 to send interrupt opcode and address of the interrupt service routine to the 8085 microprocessor. So what is interrupt service routine and what is interrupt opcode, that I'll discuss when I'll be telling you the sequence, interrupt sequence of 8259 with 8085 microprocessor. So for the time being, you just get to know this data bus buffer is used for either for reading or writing data into the or out of the microprocessor, out of this 8259 programmable interrupt controller by this microprocessor 8085. So 8085 either can write data, that is it can send control words to the 8259, that is it can write data to 8259, or it can read data from 8259 through this data bus buffer. Now next is read write logic. So the RD bar and WR bar inputs, it controls the data flow on the data bus, whether the data will go from 8259 to 8085 microprocessor or from 8085 microprocessor to 8259 will totally depend upon this pins. If RD bar is low, means if RD bar is activated, means 8085 microprocessor is reading data from 8259 and data will flow from 8259 to 8085 microprocessor. Similarly, for WR bar activated, 8085 will write data into the 8259. And when this will occur, when the device is actually selected by asserting its chip selected input low. So whenever CS bar is activated, means 8259 has been activated. See, 8259 will only get activated when CS bar is low, that is chip select is enabled. Only then 8259 is activated, and only then other pins will have their usual meaning. Otherwise they do not have any function if this 8259 is not selected. Now next is control logic. This block has an input as well as an output line. If 8259 is properly enabled, the interrupt request, again I am repeating, if this 8259 is properly enabled, means this chip select is low and 8259 is enabled, the interrupt request, from where the interrupt requests are coming, the interrupt applications are coming to this point. This 8259 can handle at a time 8 interrupt requests, and those interrupt requests are coming to this 8 inputs. These are the 8 interrupt inputs. So if 8259 is properly enabled, and if the interrupt request, and the interrupt request will cause the 8259 to assert its INT output pin high. What I am trying to say, as I have shown here also, these are the 8 interrupt pins from where the interrupt applications are coming. So if the interrupt request is this interrupt request, what it will do, it will cause 8259 to assert its INT output pin high. Now if this pin is connected to the INT bar, as we can see, this pin is connected to the INTR pin of 8085 microprocessor, and if the 8085 interrupt enable flag is set, then this high signal will cause the 8085 to respond to INTR pin through this TA bar pin. Means after getting interrupt request, the 8259 will put INT pin high and it is connected to 8085 microprocessor INTR pin, and once 8085 acknowledges this interrupt, it will send an acknowledgement through INTA bar pin to 8259. Now next is the next block that I am going to discuss is interrupt request register. Interrupt request register, it is basically used, this interrupt request register is basically used to store all the interrupt levels which are requesting the service. So it is actually dealing with all the interrupt requests which are requesting for the service. So the 8 interrupt inputs set corresponding bits of the input request register upon service request. Again I am repeating, this 8 interrupt inputs, what they will do, they will set corresponding bits of interrupt request register upon service request. So next is interrupt service register. This interrupt service register stores all the levels that are currently being serviced. So here all the interrupts are requesting the 8259 for their service, and among this 8 interrupt requests, any one interrupt will be able to get service, so that the corresponding bit for that interrupt request will get set here in interrupt service register. So it stores the currently being serviced register. Now next is interrupt mask register. Interrupt mask register stores the masking bits of the interrupt lines to be masked. It means it makes it possible to mask individual interrupt request. Means there are 8 interrupt requests. Among this 8, if we set interrupt mask register for a corresponding interrupt request, then that interrupt request won't get service because it is masked here. That interrupt request won't get serviced because it is masked here. So this interrupt mask register makes it possible to mask individual interrupt requests. And the next is priority resolver. So the priority resolver determines the priority of the bits set in the interrupt request register. As there are many interrupt requests to this 8 interrupt input lines of this interrupt request register, there are many interrupt requests. So among these 8 interrupt requests which will get serviced, it will totally depend upon the priority resolver. So priority resolver will decide among these 8 which will get service first, by actually observing the interrupt service register, by verifying the interrupt request register, and by verifying the interrupt mask register. Suppose for example, if IR3 and IR4, if the interrupt requests are coming to the inputs IR3 and IR4, if interrupt requests are coming to this 2 interrupt inputs IR3 and IR4, and suppose if IR3 is having the higher priority than IR4, what will happen? And if IR3 is masked in interrupt mask register, then what will happen? Priority resolver will first verify which interrupt request is masked, which is being serviced, and how many interrupt requests have come. Depending on that, it will let the interrupt request register to be serviced. So since IR3 is masked here in this example that I am telling you, so it will allow IR4 to be serviced, even if IR4 is having lower priority than IR3. But since IR3 is masked, so it will let IR4 to be serviced. Next is cascade buffer comparator. So this section generally controls signals necessary for cascade operations. It also generates buffer enabled signals. So as I've told you that 8259 can be cascaded with other 8259s. I've told you here that 8259 can be cascaded with other 8259s. In order to expand the interrupt handling capacity to 64 interrupt request levels. In such a case, the former is the master and the latter are called slaves, as I've told you. So, through this CAS0 to CAS2 pins, through this CAS0 to CAS2 pins, this master and slave 8259s are connected. How they are connected, that I will tell you. And this SP by EN bar pin, basically it is used for enabling the master or slave. Means if the SP by EN bar pin is tied high, then that 8259 will work as the master, and if this SP by EN bar pin is tied low, then that 8259 will work as slave. And how the CAS0 and CAS1 pins are working, let me show you here. So for master 8259, this CAS0 to CAS2 pins, they are output pins. And for slave, these are the input pins. So when the 8259 is a master, that is when it accepts interrupt request from these slave 8259s to its 8 interrupt request levels. What happened? The master sends an identification code. This master 8259 will send an identification code of 3 bits to select one out of the 8 possible slaves. To select among the 8 possible slaves, it sends an identification code through this CAS0 to CAS2 pin, which is of 3 bit. Now the slave 8259 accept this 3 signals. The slave 8259 accept these 3 signals as input on their CAS0, means it accepts this identification. All the connected to this master 8259 will accept this identification signal through this CAS0 to CAS2 pins. Through the CAS0 to CAS2 pins, it will accept the identification signal and compare the code that is sent by the master, that is compare the identification code sent by the master with the codes that is assigned to them, assigned to the slaves during the initialization process. So during the initialization process, all the slave 8259 are assigned an identification code. So what they will do, once they accept the identification code through this CAS0 to CAS2 pins from master to slaves, so it will compare the identification code with the codes assigned to them, and the slave thus selected then puts the address of the interrupt service routine during the second and third pulses of INTA bar pulses from the microprocessor. So this last line, it will send interrupt service routine address during the second and third INTA bar pulses from the microprocessor. I'll tell you when I'll be discussing the interrupt sequence with 8085 microprocessor. So this was all about the block diagram of 8259 programmable interrupt controller. Next, in my next lecture, I'll be continuing with the same topic only. I'll discuss the interrupt sequence. So I'm ending this class here. Thank you.